Imagine a heavyweight boxing match, but instead of two muscular guys we have a quantum computer and a supercomputer in the ring. Yes, you heard that right, folks. It's a clash of the computing titans, the ultimate silicon showdown. In one corner we have the supercomputer. This behemoth is the reigning champ, the tried and true, the reliable powerhouse that's been at the top of the food chain for decades. Its size alone is awe-inspiring. Picture a room, no, an entire warehouse filled with stacks upon stacks of microprocessors. That's our supercomputer, folks. It's like the Hulk of the computing world, muscular and ready to tackle any problem with brute force. But wait, who's that in the other corner? It's smaller, sleeker. This is the quantum computer, the challenger stepping into the ring. Don't let its size fool you, it's got a secret weapon. It doesn't solve problems by brute force. Oh no, it's got a more sophisticated approach. It uses quantum mechanics, the fundamental theory in physics that provides a description of the physical properties at the atomic and subatomic level. Think of it as the Sherlock Holmes of computers, solving complex problems with finesse and elegance. But here's where things get interesting. While our heavyweight champ, the supercomputer, uses bits for processing information, our challenger, the quantum computer, uses something called qubits. Now, a bit is like a light switch, it's either on or off. But a qubit, it's like a dimmer switch. It can be on, off, or anywhere in between. This gives the quantum computer the ability to process a massive amount of information at once. It's like having 1,000 Sherlock Holmeses working on a case simultaneously. So, who's faster? Who's more powerful? Well, that's a tricky question. It's like comparing a race car to a spaceship. They're built for different purposes, but when they go head-to-head, it's a spectacle to behold. Stay tuned to see who lands the first punch in this epic battle of the titans. Ever met a computer that can be in two places at once? No? Well, meet the quantum computer. Quantum computing is kind of like attending a magic show, where the magician pulls out rabbits from empty hats and makes the Statue of Liberty disappear. But instead of magic tricks, we're dealing with quantum mechanics. Trust me, it's just as mind-boggling. Let's dive into the first principle of quantum computing, superposition. Picture yourself in a supermarket standing in front of a mountain of cereals. You can't decide between the sugar-coated hoops or the chocolate puffs. In the world of classical computing, you'd have to make a choice. But quantum computing says, why not both? Thanks to superposition, a quantum bit or qubit can be in a state of both 0 and 1 at the same time, just like you holding both cereal boxes. Now, on to the second principle, entanglement. Imagine you and your best friend each have a pair of matching socks. No matter where you two are in the world, if you pull out a blue sock, your friend will also have the blue one. It's like they're connected by an invisible thread. That's entanglement. When qubits become entangled, the state of one qubit will be immediately connected to the state of another, no matter the distance. These principles allow quantum computers to process a massive amount of data simultaneously. It's like having an army of workers, each doing their job at the same time, instead of a single worker doing one job at a time. However, don't start thinking that quantum computers will replace your laptop anytime soon. They're not designed for browsing the web or streaming your favorite shows. Quantum computers are meant for solving complex problems like simulating quantum physics or cracking cryptographic codes. Tasks that would take supercomputers thousands of years to solve, a quantum computer could potentially solve in minutes. So, quantum computers are like the multitasking wizards of the computer world. But how does our supercomputer fare? If quantum computers are the wizards, then supercomputers are the superheroes, saving the day with their brute strength. Imagine a superhero, muscles bulging, lifting a car with one hand while chomping down a sandwich with the other. That's essentially what a supercomputer does. It takes on massive computational tasks, crunches through them like a midnight snack, and asks, what's next? Supercomputers are the powerlifters of the computing world. They're designed to perform at the highest levels of speed and efficiency, processing billions of calculations per second. Think of them as the Flash, sprinting through complex mathematical equations at mind-boggling speeds. But how do they do it? It all comes down to parallel processing. This is like having an army of superheroes, each one tackling a different piece of the problem. They split the job, work on it simultaneously, and then put it all back together. It's like the Avengers assembling, but with less drama and more data. These tech superheroes are invaluable in areas where large-scale simulations are needed. They're behind weather forecasting, simulating climate change effects, cracking cryptographic codes, and even simulating the human brain. Imagine someone so strong they could juggle planets. That's a supercomputer, only they're juggling data. But it's not all about brute strength. Supercomputers also have a softer side. They're like Clark Kent, mild-mannered and unassuming, yet capable of extraordinary feats. They're energy efficient, designed to perform their tasks using as little power as possible. That's right, even our tech superheroes are going green. Every superhero has their nemesis, and for supercomputers it's time. The more complex the problem, the more time it takes to solve. But just like a supercomputer never backs down from a challenge. They're continually evolving, getting faster, stronger, and more efficient. Supercomputers, the superheroes of the tech world, but who will win in this clash of titans? It's time for the final face-off. Who's your money on? Let's get ready to rumble, folks. In the red corner, we have the supercomputer, a heavyweight champion known for its raw processing power. And in the blue corner, we have the quantum computer, a newcomer with a knack for solving complex problems in a jiffy. It's like the tortoise and the hare, only this time, they're both hares and they're both tortoises. Confused? Well, welcome to the world of computing. Picture this. You're at a party and you've lost your keys. The supercomputer, like a disciplined partygoer, would start looking for the keys one place at a time. Under the couch, behind the TV, in the kitchen. It may take a while, but it's thorough. On the other hand, the quantum computer, like that friend who can't stand still, would look everywhere at once. It might end up finding the keys in no time, or it could get distracted and forget what it was doing. Now let's talk about data processing. Imagine you've got a jigsaw puzzle with 1 billion pieces. The supercomputer would meticulously place each piece where it belongs, one by one. It's a slow process, but it gets the job done. Meanwhile, the quantum computer would try to place all the pieces at once, creating a multitude of possibilities. It's a bit chaotic, but it might find the solution faster. But what happens when we throw in a curveball like cryptography? Well, the supercomputer would crack the code eventually, but it might take a few decades or so. The quantum computer, however, could potentially crack it in a fraction of the time, thanks to its ability to exist in multiple states simultaneously. So, who's winning this face-off? It's not as simple as it seems. Both have their strengths and weaknesses. They're like apples and oranges. Or should we say, qubits and bits? Well, this was a close match. But hold on, we haven't declared the winner yet. So, the million-dollar question, who won the match, the wizard or the superhero? Well, let's take a moment to peer into the future, where quantum computers and supercomputers could potentially reign supreme. Imagine walking into a coffee shop and instead of baristas, there's a quantum computer brewing your perfect cup of joe, calculating the exact temperature and brewing time down to the nanosecond. Or picture a world where your trusty supercomputer manages your entire house. It's like having a superhero butler without the spandex. But let's not get ahead of ourselves. We're still in the early days of these technologies. While quantum computers are still in their infancy, they hold the promise of solving complex problems that even the most powerful supercomputers can't handle. They could revolutionize fields such as cryptography, material science, and medicine, helping us to design new molecules for life-saving drugs or break previously unbreakable codes. On the other hand, supercomputers aren't slowing down. They're getting faster, more efficient, and more integral to our lives every day. They're powering weather forecasts, aiding in scientific research, and even helping to create realistic special effects in your favorite blockbuster movies. The superhero of computing is not ready to hang up its cape just yet. In the future, we could see a world where quantum computers and supercomputers coexist, each playing to their strengths. Quantum computers, with their ability to process multiple solutions simultaneously, could tackle the world's most complex problems. Meanwhile, supercomputers could continue to handle tasks that require high-speed, precise computations. The future of computing looks bright, and it's going to be a thrilling ride. We're on the cusp of a new era, where the wizard and the superhero of computing will work together to make our world a better place. Well, in the end, it's not about who won the match, but how they will shape our future. So brace yourselves for a future where wizards and superheroes coexist, not in comic books but in our computers.